Okay, good morning everyone, and thank you for joining us today for this online seminar where we're going to discuss cloud computing and introduce Amazon's cloud platform. I'm your host, Matt Wood. I'm the technology evangelist for Amazon Web Services, so let's get started. This always gets left to the end, so I'd just like to start off by thanking you all for your time today. I know how busy you are, and so it's a real privilege to be able to talk to you today about some of the benefits our customers see working on the AWS cloud. We're going to cover three main topics today. We'll discuss utility cloud computing, along with how and why Amazon got involved. We'll go over some of the services that make up the AWS cloud, not a full 360-degree view by any means, but I hope it'll give you enough resolution on the major services that we provide and how our customers use them. Then we'll talk a little bit about security in the cloud and how we approach that at Amazon. So you're all probably familiar with Amazon as a company, which has been running for about 18 years now and is, I guess, best known for selling a wide range of books and other products. But at heart, Amazon is a technology company with three main businesses. Probably our most well-known is our consumer retail business, which operates the Amazon.com, .co.uk, .fr, .es e-commerce sites in Europe. We also have a seller business, which allows merchants to sell items through the Amazon.com retail sites. But it's this third component, our developer business, Amazon Web Services, which I'm going to talk about in depth today. What we call web services, you may know as cloud computing, and cloud computing seems to be everywhere at the moment. When explaining the concept behind web services or cloud computing, we like to think of it in a similar way to electricity. So electricity is a utility service. It's available to you on demand, where you can use as much or as little as needed and only pay for what you use. You simply plug into the vast electrical power grid managed by experts to get a low-cost, reliable power supply, available to you with much greater efficiency than you could generate on your own. Well, cloud computing is also a utility service, and it gives you access to technology resources managed by experts and available on demand. At Amazon, we had developed a pretty unique set of software and services based on more than a decade of infrastructure work for the evolution of the Amazon e-commerce platform. This was dedicated software and operation procedures that drove excellent performance, reliability, operational quality, and security, all at a very large scale. At the same time, we had been seeing that offering programmatic access to the Amazon catalog and other e-commerce services was driving a tremendous, unexpected innovation by a very large developer ecosystem. The thinking then developed that offering Amazon's expertise in ultra-scalable system software as primitive infrastructure building blocks delivered through a services interface could trigger a whole new world of innovation, as developers would no longer need to focus on buying, building, and maintaining their own infrastructure. And the rest, as they say, is history. Amazon launched its first web service in 2006, and we now offer compute, storage, and a range of databases, ancillary services, and support offerings to help you make the most of them. So how can these services benefit your organization? Well, whether you're using EC2, our elastic compute service, or S3, the simple storage service, all our products share a similar set of attributes. They're designed to be as available as possible, which means they're available to anybody with a credit card on demand. There's no need to have to talk to me or anybody else at Amazon. You can simply sign up on our website, aws.amazon.com, and start using the infrastructure you need. They are all available via a programmatic web services interface, which means that they are easy to automate and integrate. And we also offer full elastic capability with the ability to scale up and scale back down on demand. When we're discussing the infrastructure requirements of a project, we may draw a graph like this, with time here along the x-axis and capacity on the y-axis. When planning our requirements, it's common to provide an estimate of the demand over time and increase capacity to accommodate it. With traditional provisioning, each step change in capacity is the result of a large capital spend. The problem is that real demand is much more dynamic, and over on the left here, you can see that the infrastructure is left over-provisioned, with servers that are not serving and disks that are not spinning, but which still need power, cooling, and maintenance. On the right, there is an opportunity cost, where demand starts to exceed capacity. Here there are customers that can't be served, and with traditional infrastructure, provisioning additional resources can be slow and expensive. But in an elastic computing environment, such as EC2, we can rapidly, accurately mirror the capacity for a project based on the current demand. As requirements decrease, so the infrastructure resources can be reduced, and since as it's a utility we're only paying for what you use, there's an associated cost saving. Our services are also designed to be as flexible as possible, allowing you to use only the services you need and to bring your existing skills and tool sets up into the cloud. Finally, the AWS services are low cost. They're available with no capital expenditure, and you only pay for what you use. You get to focus your engineering resources on what differentiates you and your business, rather than on the undifferentiated heavy lifting of managing technology infrastructure resources. This ultimately speeds up time to market, accelerates innovation, and increases the agility of your teams. The goal is to help customers move from their idea to a completed product as quickly as possible. Traditionally provisioned infrastructure can typically act as friction in this process. For example, using on-premise resources, at Amazon we know from experience that around 30% of a team's time is spent working on the core features of a project. The remaining 70% are spent on the undifferentiated work of managing those infrastructure resources, the friction. Our goal at AWS, and what our customers tell us they see, is that this ratio is inverted after moving to elastic on-demand provisioning. This frees up additional time for project teams to add value to the business and its customers, to innovate more quickly and to deliver products to market more quickly as well. So let's take a look at some of the services on offer. As I mentioned, we offer a broad range of infrastructure building blocks: storage, compute, databases, and a collection of additional tools and support to help build and automate your projects. So let's first take a look at storage. One of our most popular services is S3, the Simple Storage service. S3 offers scalable, available, durable object storage. We talk about objects in buckets, but you can think of them just as files in directory, housed redundantly by Amazon, and tolerant to 2 simultaneous points of failure, which means that your data stays available and secure. To give you a sense of the scale, here are some real figures. This is the graph of the number of objects stored in S3 each year since we launched back in 2006. You can see here now that we're at 762 billion objects, and they're being served up at a rate of 500,000 peak transactions per second. So all of that data is stored in S3, is private by default, and you have control over who has access to that data using access control and per bucket and per object policies. A lot of people use S3 as a private store, but you can also use it to host public-facing assets such as photos, videos, style sheets, even entire static websites. Data is stored in a geographic region, which you select when you're uploading your data. And while we mirror it for durability within that region, S3 provides 11 nines of data durability, for example, we won't move data out of that geography. Data always stays local. But with public-facing content, you might want to deliver it to your customers around the world with faster download speeds and lower latency. So to help you do that, we also offer a powerful content delivery service, CloudFront, which provides a large number of local points of presence around the world. When data is first accessed via CloudFront, it's copied to the local edge cache and delivered to customers in that area using that cache for lower latency access. It's a great service and can really make a difference to your site and your assets, but it's still available in the same pay-as-you-go, no capex model. Next, let's talk about compute. Amazon EC2, the Elastic Compute Cloud, is our utility computing service. It offers fully resizable compute capacity. EC2 lets you provision new servers, which we call instances, with a single API call or through our web-based management console. EC2 is a very powerful and flexible service. You have full root or administrator access to the compute infrastructure you provision. We support both Linux and Windows instances. Those instances are monitored and secure and are designed to be used alongside other AWS services such as S3. You can even create elastic load balancers and scaling rules to help your applications scale up and back down based on demand. Because EC2 is elastic, you can start as many instances as you need to get your stuff done. When you've finished, you can just scale back down and stop paying for your infrastructure. Applications can be deployed across a collection of what Amazon calls availability zones. These are geographically separated groups of data centers which are redundantly connected, powered, and housed. And this allows you to build your application with very high levels of redundancy and availability. In addition to the same geographic flexibility as S3, EC2 also gives you a choice of physical hardware to deploy your application on. From micro instances, which are extremely cheap and designed for low traffic personal websites and the like, to hardware that has more memory and more CPU, all the way up to our cluster compute and GPU instance types, which are designed for high performance workloads. EC2 is charged on the performance of your instance type, measured by the number of elastic compute units per hour. More powerful servers are more expensive, but you can find the right performance point for your application and not pay for any more than you need. We also have a fairly innovative choice of payment models which allow you to optimize your costs even further. We offer on-demand pricing, which is the price you pay if you just request a new instance on the website, and is best suited to unexpected spikes in your compute needs, which you may only need to last for a couple of hours. But there are a set of applications which have more predictable utilization, such as databases, message queues, or just baseline capacity. For these, we offer a reserved capacity, which allows you to reserve compute for 1 or 3 year periods for a small one-time upfront fee, but which offers much lower hourly rates, since this allows us to plan more effectively in our own operations. Indeed, we're committed to passing those savings on to our customers across the platform. As we've achieved greater efficiencies and economies of scale in our own operations, we've actually been able to drop prices for our customers 16 times without any real competitive pressure to do so. Another way we achieve economies of scale is by maximizing the utilization of our data centers. You can imagine that a certain amount of that capacity is filled by customers' reserved capacity. Another percentage is filled up with on-demand usage, and since we have so many customers, hundreds of thousands across 190 countries, one customer's usage peak will typically coincide with another one's trough. But we're still left with this additional gap, which we'd like our customers to make use of. So we allow you to decide what price to pay, and we compute the value based on demand each hour as a spot market. You can bid against it, and as the spot price drops below your bid price, we'll make that capacity available to you, with the proviso that if the spot price goes above your bid price, we'll take that capacity back again. So you do have to keep that in mind and architect for the fact that interruption can occur, but the cost savings can be huge. This makes spot instances really a perfect fit for batch processing or time-insensitive workloads. So moving on to databases. Databases break down into two main categories: relational databases, which require a schema and a good fit for structured data, and NoSQL databases, which are typically better suited to large amounts of unstructured data. Let's look at the relational ones first. Customers can run pretty much any relational database on EC2, from MySQL all the way through to Oracle, which is certified for production use and supported by both Amazon and Oracle. But there is honestly quite a lot of work involved in setting up and maintaining these databases, a lot of time and effort which companies might prefer to put into their own products and their own customers. This is really where we think we can add value. So we built a service, RDS, the Relational Database Service. RDS offers fully managed MySQL and Oracle databases which sit on scalable storage and compute and can be deployed quickly and with high availability. RDS is really a great solution for all relational database use cases, but is managed with a rich set of tools. You can look up aws.amazon.com/RDS for all the details. So while relational databases such as MySQL are great for structured data, they can be problematic when it's difficult to define a schema for your data and we're dealing with large, high-throughput data sets. In these cases, database performance can degrade significantly as dataset sizes grow, making it much harder to build queries which return results with consistent performance. So enter NoSQL and Amazon's newest NoSQL service, DynamoDB. DynamoDB is a fully managed NoSQL database provided as a service. There's no need to provision servers or manage any storage. DynamoDB is designed to work with very high throughput data streams, as it's commonly seen in log management, social networking, and gaming, with consistent I/O speeds and without the necessary overhead of configuring and managing partitions or servers or even data shards. DynamoDB handles the undifferentiated work of running that on your behalf. So instead of provisioning instances, for example, you simply tell DynamoDB how much I/O performance you need. And from that, you'll get consistent, high-performance IOPS with single-digit latencies. So to finally round out the platform, we have a collection of additional service tools and support offerings to help tie storage, compute, and databases all together. From automation and orchestration tools such as Elastic MapReduce and CloudFormation, to messaging and notification, and technical support. Technical support is available free to everyone on the AWS forums, and there's also a choice of different premium support plans available, starting at just $50 a month. So I hope you can see that the building blocks are here on the AWS platform for you to build pretty much whatever tools, services, and businesses you want. For example, Barcelona's football club's website, the Guardian's data platform, social and casual games from Playfish, analytics tools from GoSquared, who started their company on pocket money when they were still at school, to large enterprises such as Shell, Ericsson, and NASA, who run their Mars rover missions on AWS. AWS also has a fast-growing ecosystem of independent software vendors and system integrators who provide AWS services as part of our partner program, helping their own customers build scalable, reliable applications, and in creating entirely new areas for their own businesses. Partners such as Smart421, with experience with large enterprises and telcos, to CloudReach and other large ISVs and integrators such as Capgemini, Oracle, Microsoft, Adobe, Computer Associates, and Esri. You can find out more information on these partners along with case studies for application hosting, analytics, content delivery, e-commerce, and more on our website, aws.amazon.com. So just finally, I'd like to wrap up with a discussion on security. Security is something Amazon Web Services takes extremely seriously, and we've built security into every level of the Amazon Cloud platform. One of the most important aspects of security on AWS is that we operate a shared responsibility model. That is to say, we take responsibility for the infrastructure security, fire suppression systems, availability zones, physical access, everything from the foundations of our data center to the hypervisors of our virtual machines. But our customers take responsibility for their operating system and application security. Since AWS doesn't have access to the applications running on compute instances, for example, our customers need to make sure that their application and underlying services are secured and that their data is encrypted if necessary. All data stored on AWS is private by default, and our customers retain full ownership and control through a broad set of fine-grained access controls. Data can be shared privately, and access can be restricted to named account or limited by IP addresses. A word on data locality too. AWS has services available across many regions in the US, Asia Pacific, and Europe. Whilst we mirror data for redundancy and durability within these regions, we don't move data between regions. That is to say that data stored in our European region will not be moved over to the US. Our customers choose where their data is stored, and they stay in control of the location of their data, as well as the ownership and access controls of that data. One company, for example, taking advantage of this is London-based Shuttle. Shuttle is a delivery service that uses complex algorithms to enable retailers to offer two delivery options to their customers: immediate delivery from within 90 minutes, or delivery within a 1 hour time window of the customer's own choosing. Shuttle is 100% based on AWS and deals with sensitive customer information and needed to ensure that all their customer data was stored within the EU. So AWS actually enabled Shuttle to choose European-based server locations where their data would remain in the EU to help them comply with EU regulations and operate as a business. To add to this, customers like Shuttle can also make use of Amazon's identity and access management tools to provide limits on API access, console access, along with credential management and multi-factor authentication. In terms of network access to services on the Elastic Compute Cloud, Amazon provides a broad set of security settings which puts customers in control of firewall settings, opening only the ports which are required for their applications and through a service called the Virtual Private Cloud, full control over IP addressing, private and public subnets, network gateway and routing tables to build flexible network topologies and isolation on EC2. You can even bring your existing IPsec virtual private network, along with its identity and network management policies, right up into the cloud. In terms of certification, Amazon services are ISO 27001 and SOC 1 compliant, and for payment processing, the EC2 infrastructure is certified to PCI DSS Level 1. We've also mitigation techniques for distributed denial of service, man-in-the-middle, and IP spoofing attacks. All of this information and more is available in the AWS Security Center, available at aws.amazon.com/security. There you'll also find white papers on cloud security and risk and compliance, which are all well worth a read. So to summarize, we've talked about the AWS platform and how elastic utility computing can reduce time to market and increase the agility of businesses of all sizes. We've discussed the current state of the cloud and how our customers are using AWS to be innovative, to iterate quickly and operate more efficiently. And we talked to security at every level through the AWS cloud stack and its certification levels. If you'd like to know more, full details are available on our website at aws.amazon.com, where you can also learn more about how to get started with our free tier. If you have any questions or comments, please feel free to drop me an email on matthew@amazon.com or on MZA on Twitter. And with that, I'd like to wrap up this online seminar. Thank you very much again for joining us. For more information, check out our website on aws.amazon.com. If you'd like to know more about what's new on the AWS cloud, I'm delighted to be able to invite you to an in-person live event we're holding in London, where we'll discuss services such as Elastic MapReduce and DynamoDB in much more detail. I hope to see you there. Thanks again for joining us, and have a great day.